Viewers all over the world, you are welcome to Toydale online class. Today, we want to talk about addition formula. Addition formula. So, in our last class, I introduced trig. We talked about Pythagoras theorem, SOHCAHTOA, and we were able to generate the fundamental identity that says that sine square theta plus cos square theta is equal to 1. So I said this is called the fundamental identity, and it's one of the most important identity in trigonometry. So in our last class also, I said we should go and revise the special angles. We have table for special angles. Special angles like angle 0 degrees, 30, 45, 60, 90, 120, 180, 180, 270, 360 degrees. So these are special angles. They have their value. Okay. But what if we now have other angles like 75 degrees? Like if you have angles like 75 degrees, how do we find it's like 15 degrees? How do we find the sine, cosine, and tangent of this type of angle? That is the reason why we have this topic, addition formula. Addition formula will enable us to be able to find other angles that are not regarded as special angles. So the knowledge of addition formula will help us. So the additional formula can be summarized as follows. The first one, if you have sine of two angles, say angle A and B, the sine of two angles will give us sine A cos B plus cos A sine B. That's what we get. So when we have sine of two angles A and B, it's going to give us sine A cos B. You first pick the sine of the first one, followed by the cos of the second one, then plus the cos of the first one, followed by the sine of the second one. And of course, if you have sine A minus B, that will give us sine A cos B minus cos A sine B. That's what we are going to have. So for sine, that is what we are going to have. Then for cos, we also have for cos A plus B. So in case of cos now, we have to be very careful. That will give us cos A cos B minus sine A sine B. So then if you have cos A minus B, that will give us cos A cos B plus sine A sine B. Now let's see the difference. In case of sine of two angles, sine of the addition of sine of two angles, when we have sine A plus B, we first take the sine of the first one, followed by the cos of the second one. Then cos of the first one, sine. But in case of cos now, when we have cos A plus B, the operating sign here will be minus. When we have plus here, under sign is plus. Minus is minus. But under cos, when you have cos A plus B, when you have plus here, the operating sign in the expression will be minus. When you have negative here, the operating sign will be plus. So please let's take notes. Then the last one that we're going to talk about is tan A plus B. So tan A plus B will give us tan A plus tan B all over 1 minus tan A tan B. Then for tan A minus B, just change the sign. It will be tan A that will be tan A minus tan B all over 1 plus tan A tan B. So that's what you get. So how do we get tan A plus B? Just say, in our last class, we said tan is equal to, we agreed that tan A will be equal to sine A all over cos A. We note this in the last class. So if you want to find tan A plus B, just say tan A plus B is equal to tan A plus B will be sine A plus B all over cos A plus B. Then when you express everything, we are going to derive this. So these are the addition formulas. These are the formulas as we have it on the board. So we are going to use the knowledge of this formula now. I'm going to use example to be able to explain this formula very well. When you have addition under sign is addition, subtraction is subtraction, addition under cos is subtraction, subtraction is addition. Then under tan, addition, the numerator will be addition, then the denominator will be subtraction. Under tan A minus B, we have subtraction at the numerator, while the denominator have what? Addition sign. So I'm going to give example now on where we can apply addition formula. Example, let's say example one. Example, the question says that using addition formula, let me abbreviate addition formula as AF. Evaluate each of the following. Evaluate each of the following in simple in simple sorts in simple sort forms. So A, the first one is sine 75 degrees. Then B, we have cos 15 degrees. Then C, if you have to find tan 75 degrees. These are not special. These are not referred to as special angles. Though they are angles, but they are not referred to as special angles. So when we have something like this, how do we find 345 degrees? How do we express this? Then the knowledge of addition formula comes in. The first one is sine 75. Sine 75 degrees. Of course, I can break this. I can say sine 30 degrees plus 45. I can break it down. So if I want to express sine 75 in short form, I can break 75 down to 30 plus 45. So I can do that. If I do that, then from my knowledge of sine A plus sine B, I have sine A cos B plus cos A sine B. So this will give me sine 30 degrees cos 45 degrees, then plus cos 45 degrees sine 30 degrees. So when we apply the formula that we gave at the introduction, this will be the expression. Then from the special angle, ratio of the special angle tables, sine 30 degrees half, sine 30 is 0.5. So I said in the last class that we should go and revise the ratio of the special angles. Sine 30 degrees half, you have half, multiplied by cos 45 is 1 over root 2. These are known facts. We have this table in standard mathematics table. So cos 45 is this. Then cos 30. So in this case now, I'm going to have cos 30. Here will be cos 30. Cos 30 plus sine 45. Sine 45 degree. So cos 30 is 0.866 root 3 all over 2. The same thing as sine 60. Root 3 all over 2. Multiplied by sine 45 is also have 1 all over root 2. So if we open up, we are going to have 1 all over 2 root 2 plus root 3 all over 2 root 2. Of course, if we have this, we go ahead, we can add these two together. When we add these two together, we are going to have 2 root 2 as in at the denominator, 1 plus root 3. That's what we are going to get. 2 root 2, 1 plus root 3. Then we rationalize by root 2. Put root 2 here, then root 2 here. So if we express what we have there, from there, we are going to have root 2 multiplied by 1 minus plus root 3 all over 2. Root 2 times root 2 is root 4. Root 4 is 2. Square root of 4 is 2. 2 times 2, 4. This is what we are going to get. So at the end of the day, I can open up to have root 2 plus root 6 all over 4. And that's the final answer of sine 75 in short form. That will be the final answer. So we go to the second example. The second example, where we have cos 15 degrees. Of course, cos 15 degrees can be equal to cos, I can say 45 degrees minus 30. So this is what we do under addition formula. How do I get 15 degrees? We look for two special angles that either when you add or you subtract, it's going to give us what we are looking for. So, and if that is the case, by the expression of cos A minus cos B, we are going to have cos A cos B, that's cos 45 degrees, cos 30 degrees, minus, well, no, it's plus. When we have minus here, it's plus. When it is plus here, it's minus. Plus sine 45 degrees, sine 30 degrees. So what is cos 45 degrees? Cos 45 degrees 1 over root 2 multiplied by cos 30 is sine 60. Cos 30 is sine 60, that's root 3 all over 2 plus sine 45 1 over root 2 multiplied by sine 30 is half. So here we are going to have 2 root 2 all over root 3 plus 1 all over 2 root 2. Of course, when we find the LCM, it will be 2 root 2. Then we have root 3 plus 1. Then if we rationalize, we have root 3 plus 1 all over 2 root 2 multiplied by root 2 over root 2. Then I'm going to have root 6 plus root 2 all over 4. And that will be the answer. So that will be the answer that we are going to get. That will be the final answer. Then the third one is when we have tan 75 degrees. So when we have tan 75 degrees, you can change this to tan 45 plus degree plus 30 degrees. So we can break it down like that. Then if that is the case, so under tan, what is the formula? When we have tan A plus B, it will be tan 45 degrees plus tan 30 degrees all over 1 minus tan 45 degrees tan 30 degrees. So what is tan 45 degrees? So tan 45 degrees is 1 over root 3 in the special angle table. 1 over root 3 plus tan 30 degree. So 30 degree, tan 45 degrees 1. Tan 45 degrees 1. Tan 30 degrees 1 all over root 3. All over, we have 1 here. 1 minus 1 times 1 all over root 3. So here we are going to have our denominator. Our denominator, the LCM is root 3 all over 1 in root 3. So we have root 3 plus 1. So at the denominator, we are going to have 1 minus 1 all over root 3. So we also find the LCM at the denominator. So that at the end of the day, we are going to have root 3 plus 1 all over root 3. This for numerator divided by, let's find the LCM of the denominator, root 3. That will be root 3 minus 1. Then, of course, if we solve this now, we are going to have root 3 plus 1 all over root 3 multiplied by, we interchange root 3 all over root 3 minus 1. This will cancel this. So if this cancels this, then finally we are going to have square root of 3 plus 1 all over square root of 3 minus 1. We can't leave the answer like this. So from our knowledge of sort, we rationalize this will be root 3 plus 1 by the conjugate of this, root 3 plus 1. Then if we expand this, we are going to have 3 plus root 3 plus root 3 plus 1 all over 3. Just square this minus 1. So at the end of the day, we are going to have 4 plus 2 root 3 all over 2. And of course, something can cancel out. We can bring out 2. Here we can bring out 2 so that we have 2 plus root 3. So if you have 2 plus root 3 here, we are going to have 2 plus root 3 here. 2 plus root 3 divided by 2. 2 will cancel 2. Finally, tan 75 degrees will now be equal to 2 plus root 3. That will be the final answer that we are going to get. So you realize that when you are given any angle that are not special angles, then we look for a way to rewrite the angle to have 2 special angles. Then we use the knowledge of, we are going to use the knowledge of addition formula to be able to express the answer. So we go to the fourth question. The fourth question, D, is when we have sine 15 degrees. Sine 15 degrees will be what? Will be sine 45 degrees minus 30 degrees. So when we have sine, this will be sine 45 degrees cos 30 minus cos 45 degree sine 30. So this is what you get. Then we substitute. What is the value of sine 45? 1 over root 2. That will be 1 over square root of 2. Cos 60 is sine 30. So this will be root 3 all over 2 minus 1 over root 2 multiplied by half. So here we are going to have root 3 all over 2 root 2 minus 1 over 2 root 2. When we find the LCM, is 2 root 2. This in this, I'm going to have root 3 minus 1. Of course, we rationalize by root 2. So I'm going to have root 6 minus root 2 all over 4. And that is what we are going to get. So, or you can write it, say 1 over 4 into bracket root 6 minus root 2. So we have to leave our answer in solved form. Then the last but not the least, the last question, E, says sine 345 degrees. Of course, this can be equal to sine 360 minus 15 degrees. Sine 360 minus 15 will give us 360 minus 15 will give us 345. And if we express this, we are going to get sine 360 multiplied by cos 15 minus cos 360 sine 15 degrees. So I'm able to express this as this because this is a special angle. But 15 is not the special angle. But in this example, we have gotten the value of sine 15. That is the question before this, where we have d, we have sine 15. That's why I'm able to express this. So this is not the special angle, but since I know the value of this, I'm on the safer side. So sine 360 is 0 multiplied by, since sine 360 is 0, irrespective of what cos 15 is, everything here will be 0, minus cos 360 is 1. I'm going to have 1 multiplied by, I've gotten the value of this. I've gotten the value of this to be root 6 minus root 2 all over 4. Then from there, I'm going to have minus root 6 minus root 2 all over 4. When I open up, I'm going to have root 2 square root of 2 minus square root of 6 all over 4. And that will be the answer. So if you look at that properly, if you do it properly, that is what we are going to get. So we have been able to use the knowledge of addition formula to be able to solve the given example. So let's take one more example before we call it a day. So example 2. After this example 2, then we can close for today. If alpha and beta are acute angles, of course, acute angles are angles that are less than 90, such that sine alpha is equal to 8 all over 17 and cos beta is equal to 3 all over 5. The question now says find without using tables. The first one, we have to find cos alpha minus plus beta. Then the second one, we have to find tan alpha minus beta. Then C, we have to find sine alpha plus beta. Of course, since we have tan here, then there's need for us to find cos alpha, tan alpha, then cos alpha, cos tan beta also. So when we look at this first one, solution. When we look at this first one, let me just sketch the triangle and call this place alpha. What is sine? Sine is opposite all over hypotenuse 17. Then there's need for us to find x, which will be the adjacent. Because if I want to express this cos alpha plus beta, this will be cos alpha cos beta, cos alpha cos beta minus sine alpha sine beta. So I know sine alpha, but I don't know cos alpha. So there's need for me to find this adjacent to be able to know cos alpha. So in this case now, if I want to know this x, I'll just say 17 squared is equal to 8 squared plus x squared. Pythagoras theorem. So 17 squared will be 289. It's equal to 64 minus plus x squared. So 289 minus 64 is equal to x squared. So this will give me 225 square root is equal to x. So x is equal to 15. So here, my x is equal to 15. So I know sine alpha. Since x is equal to 15, that simply means that I can get cos alpha, I can get tan alpha. With this, I can get cos alpha, tan alpha. So let me just note everything somewhere there. So I won't rub it off. Here, I have sine alpha. We are given sine alpha to be 8 all over 17. Then since I've gotten the value of x, I can find the value of cos alpha. Cos alpha will be adjacent all over hypotenuse. That is 15 all over 17. Then tan alpha will be opposite all over adjacent, 8 all over 15. So we have gotten that. Then we go to the second value that we are given, where we have, I'll draw another triangle also, where I have beta. cos beta is adjacent of hypotenuse. So this will be 3 all over 5. So let me say this is y. Let me find the opposite. I'll find the opposite here. I would now say 5 squared is equal to y squared plus 3 squared. 25 is equal to y squared plus 9. So 25 minus 9 is equal to y squared. So 16 square root is equal to y. So y is equal to 4. So in this case, y equal to 4. Y is equal to 4. So also we know cos beta, we can find sin beta, we can find tan beta. So here I'm going to say sin beta now. Sin beta will be sin beta opposite all over hypotenuse 4 all over 5. Then tan beta will now be 4 over 3. 4 all over 3. Then we are given cos beta. We are given cos beta to be equal to 3 all over 5. So we have gotten the value of everything that we are required to find the given problem. So the first one, A, we have to find cos alpha plus beta. So how do we get cos alpha plus beta? From the expression, of course, we know from the expression, when we have cos, the same thing as cos alpha cos beta. When we have plus here, it will be minus here, minus sine alpha sine beta. So what is cos alpha? Cos alpha is 15 all over 17 multiplied by cos beta. Cos beta is 3 all over 5 minus sine alpha. Sine alpha is 8 all over 17 multiplied by sine beta. Sine beta 4 all over 5. So if we do that, of course, 5 can take care of this. This is 3. I'm going to have 9 all over 17 minus 9 all over 17. So I will have 9 all over 17 minus 32. 32 all over 85. That's what I'm going to get. Or let me just leave this as 15. Let me leave this as 5. So that I will have 45. 45 all over 85. So the LCM is 85. I'm going to have 45 minus 32. Then finally, I will get 13 all over 85 as the value. So cos alpha plus beta will give me this. Then I'll go to the second question. The second question, where I have tan alpha minus beta. Of course, from this expression, I'm going to get tan alpha minus tan beta all over 1 plus tan alpha tan beta. So if that is the case, we know the expression for everything is on the board. From there now, I'm going to have what is tan alpha? Tan alpha is equal to tan alpha is equal to 8 all over 15. 8 all over 15 minus tan beta 4 all over 3. That will be 4 all over 3. That's for the numerator. Divided by denominator, I have 1 plus tan alpha. Tan alpha is 8 all over 15 multiplied by then tan beta. Tan beta is 4 all over 3. So here the LCM is 15. 8 minus 3 here is 5. That's 20. So that will be 8 minus 20 divided by 1 plus, I'm going to have 32 all over 45. That's what I'm going to have. So here I'm going to have minus 12 all over 15 divided by, if I find the SMA is 45. So I'm going to have 45 plus 32. Then from there, I'm going to have minus 12 all over 15 multiplied by 45 all over, here will be 77. Here 1, here 3. So at the end of the day, the final answer will be minus 36 all over 77. And this is what we are expected to get for tan alpha minus tan beta. Then lastly, we do the last question. See, that is where we have sine alpha plus beta. So when we have sine alpha plus beta, what will be the expression of sine alpha plus beta? Sine alpha plus beta will be sine alpha cos beta plus cos alpha sine beta. So what is sine alpha? Sine alpha is 8 all over 17 multiplied by cos beta. Cos beta is 3 all over 5 plus cos alpha 15 all over 17 multiplied by sine beta. Sine beta is 4 all over 5. So from there, we are going to have 24 all over 85 plus 60 all over 85. So the LCM will be 85. We have 24 plus 60. Then at the end of the day, we are going to have 84 all over 85 as the value. So we are going to have 84 over 85 as the value. So that will be the answer to sine alpha plus beta. So I would love to stop the class here. If you have any further question on addition formula, you can just write at the comment section. I promise to attend to it. So for addition formula, we know we can do that of sine A plus B, where A and B are angles. So sine A plus or minus B have its own expression. Cos A plus or minus B have has its own expression. Then tan A plus or minus B also has its own expression, as we have shown in this class. Thank you for listening.